You guys ready for your math lesson today? For your learning grid? Check this out. Today we're going to look at something called inequalities. And it's a beautiful day, so I'm outside. If you hear birds chirping or anything like that, it's part of nature, man. You got to love it. So let me tell you a little story to start off with. I went to this little tiny minute market on the corner the other day, and there was a sign posted on the window that said, maximum 10 people in this business at a time, right? So the reason for that, of course, is they want to spread people out and give them a chance to social distance. And if it was crammed full of people, that would be impossible. So I thought, of course, because I love math and I want to teach you guys more and more math, how could we create an equation that expresses this idea that only 10 people could be in the store? So I said, all right, well, let's think about X. X is going to be the number of people, right? And so X could equal 10, right? X could be 10 people in the store. But I don't know. I'm standing in the store and I was looking around and there was only one other person in there. So there's only two of us in the store. So if X is the number of people and that happens when you're outside, and there's only two of us in the store, then X doesn't equal 10 there. X equaled 2. So my equation doesn't work. How can I make something to quantify this idea that the most amount of people that can go into the store is 10? So I started thinking about it, and that's where inequalities come in. So inequalities are like equalities, or like the equal sign, except for they have the prefix in in front of them. And if you're really up on your prefixes, you know that the prefix in means not. So here I've got inequalities instead of equal signs. Not equal. So I'm not going to use an equal sign here. I'm going to use something else. You've probably seen these symbols before when we compared things like 3 and 4. Well, 4 is greater than 3, or 3 is less than 4. So let's take this back to our idea of I'm in this store and I can only have 10 people or less in the store. Is X, which is the number of people, is X going to be greater than 10 or less than 10? Well, X needs to be less than 10 because I can't have more than 10 people in the store. So boom, there we go. X is less than 10. I've made an equation. It just happens to be an inequality. Let's try a different one. So I'm at the dinner table with my daughter last night, and she wants to be done, but she hasn't ate all of her vegetables. She's got some broccoli left on her plate. Now there happens to be more broccoli than she's willing to eat, and she's very full. So I look at it and I think, okay, well, you have to eat 4 or more bites of broccoli. So here, X is going to be our brock. All right? So X equals how much broccoli we're talking about. And I've got X, and I've got this number 4. Now she has to eat 4 pieces of broccoli or more. This time, my symbol should go the other direction. X has to be greater than 4. So she has to eat like 5 or 6 pieces of broccoli. But I think my daughter might grow up to be a lawyer. And she says, Dad, you said I have to eat 4 or more. But this equation you're making here says I have to eat more than 4. You said 4 or more, so I can eat only 4. What do I do different to my equation here? Well, it's not that tough actually. I put a little line underneath it. So now I have a greater than or equal to 4. X is greater than or equal to 4. Now it includes 4 and everything more than 4. And you know her? She only ate 4 pieces of broccoli. And then she asked for dessert. That, amazing, right? You guys never do that, right? Do you? Nah, you probably do. So we can make all of our inequalities to be something is greater than, something is less than, something is greater than or equal to, and something is less than and equal to. Now, not only can we use these symbols, but we can represent these ideas with another great math visual product. And that is turning this whole thing into a number line. Now you're like, but I already know the answer. Why would I do the number line? Well, the number line's a beautiful thing, actually. I'm going to show you this number line. And we're going to look at the broccoli problem. Now, here I might have 2, 3, 4, 5, and 6. And these numbers represent how many bites of broccoli my daughter might eat. Now, I said she has to eat 4 or more. So what I do is I locate 4 on the number line, and I make a little circle. And then, is she going to be able to eat less than 4 or more than 4? Well, it's got to be more, so I make a little line here with an arrow signifying everything is included past 4. Now, what do I do with this circle? Because we had decided, when we argued, that 4 was included. Because the number 4 is included, I don't want this circle to be empty. I want it to be just like the line, and I fill it in. I fill it in. So, anytime I'm making these number lines, very simply, if it includes the number, the circle is filled in. If I said, nope, girl, you got to eat more than 4, 4 doesn't count, then I would change my number line to not include the 4. All right? So this one says x is greater than or equal to 4, and this one says x is greater than 4. Now, of course, if I was talking about less than, I'd be going in the other direction, right? Okay, this should give you everything you need to tackle this week's assignment. If you have any questions, ask me or ask your teacher. Try it. Please watch these videos all to the end. They're really worth it. I probably should have said that at the beginning, because if you watched it to the end, you already heard me say it, and you're at the end. I kept it under 8 minutes. Get your work done. Do it right the first time. Take your time. Check your answer. See if it makes sense. All right, guys. Thanks for watching.